Hi again.
Yeah.
Oh. Thank you for such a warm welcome. Let me start with a direct example. So let me skip for a moment. I don't have that many slides for this talk, so let me switch immediately to Visual Studio and to something that is already up and running. What I have done, nothing fancy, nothing special. I just launched on the local host the sample application I have with as a companion benefit with this talk. By the way, the code will be available, is already available on public URL, and I will share the URL at the end. So we have a couple of browser windows here. One is Internet Explorer, the other one is Chrome, and I have the same page displayed with one button, Start Remote Task. I start the remote task on one browser window. At some point I start here. Are you ready? Okay. And this is amazing. Chrome is, it's cool. This is an unwanted feature. It's really cool, but it's an unwanted feature. Let's say, okay. Okay, now Chrome is start working. So what I wanted to show is that essentially I'm simulating the amount of work being done remotely and how I report the amount of work in a way, in terms of a number, as a measurable quantity on the client to display that. And the reason why I used two independent browser windows and even two independent browsers is to show that every operation is monitored in an independent way. I'm not sure if it really shows. Chrome is really nice sometimes. But if I'm able, if I can manage this. So this is a GUID, and this is a different GUID. So that is, of course, important to figure out the fact that monitoring is taking place independently. The technology behind this feature, which has been the dream of a generation of developers, at least those with some gray hair that have been in the industry for quite some time. There was a time in the beginning of the web development era, some 10 years ago, in which everyone was really craving for this kind of feature. Today, and it's been a few years now, thanks to SignalR, we can get this up and running. This said, let me switch back to the slides and let me briefly summarize what are we going to talk about. ASP.NET SignalR is essentially server-side code that runs, exists, and once configured, it works by pushing content to any or selected connected clients. So you have both options. You can send a content to all selected, all connected clients, so you can broadcast. That's the technical term in the jargon of SignalR. You can broadcast content to whatever connected clients you have, or you can programmatically from the server side decide to send content to a specific connected client or a group of connected clients. And the GUID that you briefly saw showing up on the screen demonstrates that that is the key that identifies the connection that will receive content pushed from the server. How how does it work? There are, let's say, two levels at which we can learn and imagine the behavior of SignalR. The high-level view can be described in the terms that follow. The browser does something, we will figure out exactly what, but the browser does something, so every page, every web page, every HTML view in front of the user that is expected to receive content pushed from the server, so this may be every page in a web application or just a few, has to do something to start the SignalR connection. And starting the SignalR connection is a client-to-server communication that, of course, takes place over JavaScript. I say, of course, because, well, it makes not much sense that we go to the server, refresh entirely the page if we want to receive content being pushed. We will be invalidating the entire theory behind SignalR. After the communication, the channel between a particular browser instance, a particular browser session, and the web server through our application has been established, what happens, what I've called here generically long polling, depends on a number of factors, but all of these factors are, for the most part, outside the reach of us developers. So SignalR provides a high-level programming interface for us to start and just wait. But the way in which the real application waits, well, that depends on both the nature, reads capabilities of the browser, and the way in which browser capabilities in terms of web protocols match the web server capabilities. Nicely enough, maybe in the next demo, you will see, or I will try to point out that the same application, so the same piece of code run from the local host and running hosted on a public web server running IIS will be using different protocols for the long polling kind of thing. But anyway, trying to abstract, once the connection is established between a browser session and the web server, there is essentially a mechanism that makes the browser ready to receive data. This can happen in the simplest case, that will happen through long polling. So the browser sends another request to the server that keeps the connection open, and the request has a timeout set, and either there is something that closes the connection providing a response from the server within the timeout, otherwise the request times out, and after that automatically the client-side part of SignalR will reissue another request to keep on waiting for a longer time. This is essentially nothing really different from classic plain polling, a remote resource, a technique that I think everyone understands very well. Long polling is just a more effective, slightly more effective technique that minimizes the number of requests being exchanged between the browser session and the web server. At some point, however, there is a response that from the server goes back to the client. Now, between the start and the response, the long polling, if both the browser and the server are smart enough, by smart enough I mean they support advanced protocols like, say, WebSockets, then there is no polling at all, but the request for send me data and the response will take place essentially over sockets managed according to the WebSockets web protocol. But that depends on whether both the browser and the web server are able to support WebSockets, and I can tell you that probably not even the latest maybe just the latest version of IIS, but I mean, on the web server where I have hosted the sample application, I think it runs IIS 8, well, it has no support for WebSockets. And you will instead notice that when I run locally from IIS Express or Windows 10, the protocol is WebSockets, so IIS that comes with Windows 10 has support for WebSockets, but not the version of IIS on the web server where the sample application has been hosted. And here is the list of, to the best of my knowledge, of the web protocols that are possibly used by SignalR, and I would say the choice of which of those protocols is selected is not a configurable aspect. On the other hand, if you use SignalR is essentially for the high-level programming interface. If for whatever reason you reckon, if you have measured, just to quote my friend Marco and his previous talk on performance tuning on aspects of the Stack Overflow website. So if you measure and you realize that by using SignalR, you are losing it, your requests are taking too much, and you want to try to get better and better performance, the best thing you can do is, for example, using WebSockets directly, even though this could set some requirements to be verified on both browsers and especially the web server. So WebSockets, server-sent events, long polling, and forever frame are a few of the protocols. I think the only protocols that at the moment the latest SignalR is able to recognize and support. So there is browser and web servers compatibility, and when this is established, essentially there is a bidirectional, that's important, bidirectional exchange of information. It means that the browser sends a request to start, let's say, polling, but what polling means waiting for some response to come. And when this happens on the server side, there is a server-side SignalR infrastructure that your business code, whether it is the controller, whether it is the SPX page, whether it is something deeper in your hierarchy of code, so the application layer, the domain layer, even infrastructure layer. So wherever you have a piece of server-side running code, from there you can call back the server-side SignalR to instruct it to pass back data to the client using the protocol. And the details of how this happens is entirely hidden from view, and, well, I think this is absolutely acceptable. If you need more, if you need to take control of this kind of things, stop using SignalR and just using the WebSockets, W3C standards, and some sort of implementation you have. Now, this is a sort of a high-level architecture of how it works. As you can see, it's a sort of a circle in which there is an element which is the browser. There is and underneath the browser, there is something called the JavaScript SignalR hub. On the server side, there is your ASP.NET code. So again, it can be controller or whatever other layer of code you have. And there is some initialization code also on the server. And then there is the hub, which is essentially the server-side code that is technically responsible for pushing data back to the client on whatever channel or whatever set of channels your logic requires. So it's the hub, essentially, that decides whether a given amount of data that is available on the server should be broadcast to whatever device, whatever browser session is listening and connected, or just one or a group of. On the client side, we need to have to reference a few JS files, essentially the SignalR jQuery plugin. And then there is another reference, /SignalR/hubs, which is embedded in the client in the form of a script tag, even though apparently there is no JS file, no static JS file that is downloaded. The fact is, the neat effect is when the browser processes the SignalR/hubs URL, on the server side, there is some work that takes place that generates and downloads some JavaScript proxy on the client. That is exactly the code that you use to start the connection. Okay, this is said. Before I switch entirely to code and demos, let me briefly fly a little bit higher. And okay, SignalR is a pretty cool piece of technology that is gaining today and even more in the near future really a lot of relevance for one particular reason. Anyway, in general terms, there are three macro areas of functionality that you can where you can think of using SignalR in your applications. Broadcast, so where at some point you can envision in your application space for just broadcasting information about something that has happened on the server to any connected device. Or you can choose a direct communication towards one particular browser session or a group of related browser sessions. Another third macro functionality is counting users online connected to your application, and perhaps group size of logically related groups of users that are currently connected to your website. Now, more specifically, SignalR is crucial, and you may remember from my talk this morning that at some point I briefly mentioned, was it the talk or was the after talk? Probably it was the after talk. It doesn't matter anyway. So one of the issues that I see at the moment, just today, December 2016, around ASP.NET Core, is that it doesn't support yet SignalR. So SignalR is not usable today with ASP.NET Core. It is scheduled for the next release, which will be 1.2, which, as far as I know, or rather, as far as it is public, because I have no under NDA information to share, is scheduled to be available in the first quarter of next year. So it's just a few weeks away from us. At the moment, it's not supported, but it's extremely crucial and critical because it is the primary tool to use in a CQRS applications. So applications architected according to the CQRS pattern to refresh the screen after a server-side operation. So, in brief, a CQRS architecture is an architecture where you have two neatly separated, physically separated, I would say, stacks. One taking care of the commands, so the processes, the server-side tasks that alter the state of the system, and the query stack, so operations that the user triggers from the presentation that just report the current state of the system without altering anything. So the problem is, according to CQRS, you perform an operation and you are not expected to report data back. But in the web context, in the context of regular business applications, so classic front-end based apps, well, it is acceptable that the request that processes the update doesn't return directly data, but still you have to show something to users. So you have two options, essentially. One is using the PRG pattern. You post, you redirect, and then through the redirection, you get data refreshed, the page fully refreshed. So the redirect is a direct get operation. So the post and the get are neatly separated because they belong to two distinct HTTP requests. This is one approach that has the issue, the drawback, that it requires a redirect, and more than that, it requires a full page redraw. The alternative is you place the command, you push the command through JavaScript, so you post the form or you order the operation via JavaScript. At that point, you have to refresh in an asynchronous manner the screen, and in this case, SignalR is just perfect for the job. And I had the chance to talk to a few of you during the day, and a couple of them reported, asked questions about using SignalR in the context of CQRS. So this is the point, the aspect that makes it very critical. More in general, SignalR is great to notify views of relevant things that have happened in other pages. Facebook. That's it. I don't know if Facebook is really using SignalR, or given the numbers they have, they probably use it directly WebSockets or other protocols. So if Stack Overflow does all the magic they do to optimize and squeeze every little bit of performance, I guess that Facebook, which is immensely larger as a company than Stack Overflow, probably they do analogous things. But if you try to imagine in your small application a scenario in which you have users with different roles connected to the application, and there is the low-level user that writes something, makes some applications, tries to book something, and then there is a manager user that receives in real time the notification that someone has made changes to the list of things he has to approve. So imagine a manager reviewing things he has to approve, and an icon that pops up to say, oh, the list you have in front of you right now is now not the most updated because some changes have occurred, so please refresh the screen. Or you could even, if that makes sense, even automatically refresh the screen under the nose of the manager user if something has changed. So you can implement things like that, or in a sort of a social style of application, if you have users related together by a relationship of friendship, when someone updates the profile, you can serve immediately the update to others. So there are, in general, there is the ability to update asynchronously views or notify of changes, whatever page, whatever view in an application. And as mentioned, and as briefly demonstrated, you can use SignalR to monitor the progress of a server task, the percentage of work that has been performed, but it doesn't have to be necessarily numbers. It could be just messages. We reached this stage, or the request is pending, is waiting for approval, or this or that, or whatever else. And, okay, we will now focusing on precisely this demo to start. And this is the URL where you can grab the bit.ly, whatever. That is for the source code. The other one instead is the official Microsoft page for getting started, beginning kind of information. Okay, I will get back to this particular URL later. Anyway, consider the web code, the source code will be available also through the site of the conference. Now back to Visual Studio, and let's take a look at what happens, how you configure and how you build up the progress bar example. The first thing we notice is, okay, first and foremost, you have to install the SignalR NuGet package. And that's the first step. And after that, we end up with a startup file in our application. This startup file is pretty basic, pretty simple, nothing special in it. Okay, it's startup CS, but we are talking about non-.NET code. This is a regular .NET code. Yet there is an OWIN interface that is used to interface your application with the underlying web server. So the class, the startup class, has two particular things to be noticed. There is a configuration method with exactly that signature where you call app.mapSignalR. And then you have to declare that this particular class is the OWIN startup class. And you do that with an assembly directive. You can place the directive here, right on the class, or perhaps, if you like it most, in the assembly info file in the Visual Studio project. So that's the absolute beginning code for starting up, for initializing SignalR. After this, let's take an HTML page. For example, there's one, it's called task. Okay? This is the page that I used with a start button. Here we go, start remote task button. And when this button is clicked, magic starts happening. Now, let's take a look at the script files registered at the top that you must have in every view, every HTML view where you plan to use SignalR. You reference from a CDN or from your premise, it doesn't matter, the SignalR jQuery plugin, and then you place the call to SignalR/hubs, which has to be rooted in the root of your application. So this is a request that goes to your own web server where the code is hosted. Beyond that, in our page, there is a button that starts the task, and this JavaScript function is defined in a JavaScript block. Here we go. As you can see here, this is a trivial jQuery post or get or whatever it is call. So it's whatever JavaScript code you want to use to call back a remote SignalR-enabled endpoint. So in this case, I'm talking the lengthy method on the task controller. And first aspect to notice, I want, for the nature of the operation, I want to establish, I want a direct channel between the browser session and the back end. So I want to have a direct form of communication, not broadcast. So I have to pass, there's no other way. I have to pass some way the connection ID to the server. So I need to tell the server side, the SignalR, please get back to me using this connection ID. And okay, as you can see, connection ID is a JavaScript variable used here, declared here as the empty string, but there is apparently no place where the connection ID is initialized. And that is the second piece of magic. There is, and that's mandatory, another chunk of JavaScript, a sort of SignalR JavaScript initialization code that you need to have. Okay, first things, it's this. Local variable, the hub local variable is used and defined essentially as a convenience. You can even use the expression $.connection progress hub directly. So the variable is just for my personal convenience. But let's say we have such a variable. $.connection is the root object of the jQuery plugin for SignalR. Progress.hub, that is an object that we are referencing that has been automatically generated. So it's a part of the JavaScript code injected in the page by the SignalR/hubs JavaScript call. So this URL here injects in the DOM of the current page something called Progress Hub. And we will see in a moment that why Progress Hub? Because Progress Hub is the name of the server-side hub class I have defined on the server side to push messages back. So there has to be a conventional match between the name of the JavaScript hub and the name of the server-side hub. Okay, once I have this, I run into this code, connection.hub. Hub is now a generic object which is part of the SignalR plugin, and I call the start method. So in this way, I'm trying to start the connection between this browser instance and the SignalR backend. There is the done promise, and when done, so when this function starts working, it means that the connection is established, and I can start safely sending requests to the backend. And what I do here is two things. One, I save the ID of the connection, but I receive the ID of the connection from the server side. So it's the system, it's the SignalR system that tells me, okay, this particular connection has been established, and this is the unique GUID that identifies that. So I save that to the connection ID variable, and then, because I want to give my, okay, let's say users of this application a safe and possibly smart interface, only at this time I enable the button that can trigger the task. Because the button, as you can see, is disabled by default. And this disabled attribute is removed via jQuery only once the SignalR connection has been established, which means that at that point, I'm able to safely try to connect to the backend. What about, there are three more functions here. Let's skip over the role of these functions for the time being. So at the moment, we are perfectly able to trigger, to set up a connection between this particular instance of the browser and the server side. Okay, at this point, when I push the button, I move my attention to task/lengthy. And I have, on the server side, a controller class, task controller class, with a method called lengthy. So this is the code that runs when I push the button. Okay? What this code does is essentially, the logic here just simulates the progress of a task. It does that by picking up a random number which indicates the step of the increase. And let's say that this task is a task that contains logic, say it's a workflow, through which I want to take note of reached states and notify the achievement back to the client. Whenever I need to do this, I create an instance of a hub class. Now, Progress Hub is my server-side class. It belongs to the application. It's my own code. And this code shows up here. So it's a class that inherits from Hub, and Hub is a SignalR, part of the SignalR framework. This class has methods that refer to the things I want to notify back to the client. So here is one method per type of notification I want to make, and this is a list, a business-oriented list. So it depends on the things I want to notify about the specific task. So imagine you have a hub class per each, essentially, view, or per each task you want to monitor. Okay? So in this case, I want to monitor when the task starts. So I have a notify start. I want to notify the progress. So it started and it reached this amount of work, and then notify end, the task is finished. The signature of the methods here is up to the developer, but notify start, at the very minimum, I have to receive the connection ID through which the message should be sent back, so con ID. For end, I just want to notify that the task running over this connection has ended, so no additional parameter. Notify progress, it means that over this connection we reached, we have done this percentage of work. This said, the code we find in this method is pretty trivial. The first line is standard code. I ask the SignalR infrastructure to get me the hub, the current hub, being used over this, this connection. So say, give me the internal object I have to use to message back to users. So you will take a line like this, global host dot connection manager dot get hub context, and then T. T is your hub class. That's it. You get back, you are returned a hub context object, and then this is where things start getting interesting. Once you have the hub context, the next thing you have to decide is what is the target of my message. So hub context is the class through which you message back potentially all, some, or one of the connected clients. And you decide how many and which based on the business logic of your application. In this particular case, I say from all of the connected clients, pick up the one connected over that particular connection ID. And then how the message back happens. Simply calling a method, init progress bar, and again, by convention, this name matches the name of a JavaScript function defined on the other end. Let's explore this further on the progress thing. The context here, I pass the connection ID, and I call the update progress bar, and I say, over this connection, we have done this amount of work. And percentage and the hub method is called essentially during the for that simulates the progress of work. So every time I finish a for step, I call notify progress on this connection ID. That is the total amount of work. And I wait a couple of seconds just to simulate time that takes. And when everything is finished, so notify start, notify progress a few times, and then notify end when it's finished. Back here, on JavaScript, on the client, here is init progress bar, update progress bar, clear progress bar, and you are welcome to give these methods the name you like, as long as there is a match between the name of the JavaScript methods and the name on the server-side hub. They have to match. Update progress bar receives a number, which is the percentage, and what happens here is up to you. I mean, in this particular case, the HTML contains a bootstrap progress bar, and basically what I'm doing here is just configuring the bootstrap, via JavaScript, the bootstrap progress bar to move it, the colorful part, to the specified amount of work. Great. This is the way in which SignalR works. Now, let me invite you to have your phone ready, please. I want to involve you to try to make a demo to see if it works, and then I will finish the presentation. Essentially, how is that? Broadcast. I typed it wrong, so it's broadcast. Okay. Okay. You can, if you can scan this QR code, you can go directly to a URL. Otherwise, I can tell you that the URL is. Can you scan this? Okay, cool, perfect. Let me leave this here for a few more seconds. And meanwhile, you can take a look at the protocol message over there. This is running from the local host, and the protocol is WebSockets. Okay. Now let me switch to the published version of this, which is expoware.org, and it's up here. So this is on a web server, and well, it's still working. 39 voters, 441 voters, and if you push the buttons, yeah, okay. Cool. Oh, you can only choose, I'm sorry, only exceptional or fantastic. I'm sorry. Well, it's fair on my hand to ask you, oh, it's fantastic. It's fantastic is winning. So that's SignalR, essentially. That's an effect of SignalR. Remotely, you can, until I stop voting, and also the number of voters is changing as people connect or disconnect to the website. Okay, at some point I reset. So it's not really effective as a voting system, but you get the point that is behind that. Look, we are now talking to this application from expoware.org, vote, broadcast, and whatever, and the protocol is different. It's forever frame. That depends on the capabilities of the web server. I'm using in particular Internet Explorer 11 on my machine here, but the web server is not able to support WebSockets. The IIS Express on Windows 10 is able to support, let me stop this. Thank you very much for your vote. 4.4 is perfect. Half the audience believes it's exceptional and half fantastic. I really don't know which one is best, but anyway, it doesn't matter. Now, this said, the code behind is is even simpler than the code I just showed to monitor the task. Let me bring that up. And we see that the close vote. It's vote first. So this is where I start the connection, and the page has two buttons, exceptional and fantastic. Okay, so when you click, say, exceptional, starterkit.post, starterkit is just my fancy name around the jQuery post function, so nothing fancy, it's just jQuery. So a call is placed to broadcast/vote, passing E in the body of the function. And after that, I simply suspend for 3 seconds the button, which you may have noticed remains unusable for a short amount of time. So there is a simple call made to an application endpoint, and the broadcast vote. Let's retrieve briefly the broadcast controller here. This is the vote method. It's a post, so we are here. And, well, quite simply, if we received E or F, depending on that, I call exceptional or fantastic on vote hub. And vote hub is, again, a class that inherits from hub and has something called fantastic and something called exceptional. And then I use clients.all to broadcast the message to whatever application, whatever device is connected. There is, to count users, something different. There is another hub somewhere. Where is this? I'm lost. The framework. Here we go. The counter hub. The counter hubs, and this is a standard way of essentially counting the users. We have, a static, read-only array, online users, just strings, and leveraging on-connected, on-reconnected, on-disconnected methods on the hub class, overriding those methods, we are notified on the server side when a client gets connected, reconnects, or is disconnected. And of course, based on this, what I do is I update the list of connections I hold in my array, and through update user count, I just notify back through update online users the JavaScript page, and it should be here. Exactly, here we go. And Well, when this function is invoked, some piece of the HTML is updated with the number of currently connected users, and you have noticed that the number may be growing or decreasing depending on how browsers connect or disconnect or reconnect. This is the power of SignalR. So these are the three macro functions: broadcast, direct calling, counting, and expanding these three macro areas, we can essentially cover two big and important business scenarios: secure a refresh of the screen in the context of CQRS applications, and in general, making cross-page notifications and even cross-user notification, so that we can promptly notify a connected user that some data of his or her interest has been changed meanwhile. For the cost that implementing SignalR represents, this is honestly, and I say this on the base of experience, it's a fantastic feature to have. Thank you very much for your time.